Okay. Hello once again. Yeah. Cool. Let's work. I was gonna say, I think on my videos, bro, I have to find something that I say like in the beginning of my videos, cause like, hey, bro, it becomes so weird. I'm like, okay, what do I say on this video? Then sometimes when I say hey, it becomes weird. But let's work. So, on this video, we're gonna talk about nominal interest rate and the effective interest rates. Right. So, the idea is very simple. So, from the questions we have done, especially when we're dealing with number lines, we came across many interest rates that were compounded monthly, quarterly, half yearly, and so forth and so forth. I think in the examples we did together, we didn't see one where it was compounded daily, but yeah, we have such, right? So all of those interest rates, we call them nominal interest rates. Now, yeah, we call them nominal interest rate. I'll give another better or clearer explanation of nominal interest rate. And then we have on the other side effective interest rate. So the effective interest rate is the simple interest rate that gives you the same accumulated amount. Yeah, for the same duration, for the same duration, say 2 years. If you make it an investment of 1,000 rand for 2 years, for option A, the interest that you have is a simple interest, right? Option B, it's a compound interest. Yeah, this comes to that better explanation of nominal and effective. It's a compound interest compounded. You have your interest rate compounded, say quarterly, right? Yeah. So on the quarterly example, you put on the number, you make your calculation. After 2 years, this is how much you get. You see, that same value, that same accumulated amount. When we go to the simple interest, we find the interest rate that can give you exactly that same accumulated amount you got when you used your compound interest, right? So we find the interest rate, the simple interest rate that gives you the same accumulated amount if you invested the same value, which is 1,000, right? Yeah. So in short, we would say usually yeah. Usually, the nominal interest rates, they are usually your compound interest, right? And of course, they will be compounded differently. Yeah. Some yearly, some like I've said. But yeah, that's just the definition. We're gonna do something a little bit interesting here. So say for example 1,000 rand. I love 1,000 rand. So say 1,000 rand. Oh my god. Okay, I need to do this. Go here. Okay, so you have 1,000 rand and you make 1,000 rand deposit into a savings account or like whatever investment account, and then come on, you get an interest rate of 9.3% per annum, compounded quarterly. Oh, let me not say anything yet because these are how it will be compounded, right? So there's something about yearly compoundments that are interesting. So you would see that if our interest rate have been compounded yearly, that simply means that our nominal is the same as our effective rate. We're gonna prove that, we're gonna show that, and then do a few examples. So with this, okay, we have yearly, half yearly, quarterly. The same. This is invested. So this we only make our calculation. We make our calculation on this 1,000 rand being our principal and this being our interest rate. What we are changing is these things. So I'm gonna quickly pause and fill it out. All right. So after you, of course, this is like how our calculation is going to be for all of these, and you can see half yearly, that is 2, quarterly 4, monthly, do you know what I mean? It goes like that. Then I'm gonna pause the video again, put all these values in a calculator and write their answers here, just not to make, I don't want to make this video too long. Yeah, cool. So you put everything here on a calculator, they give you the corresponding values, which is your accumulated amount. And then what happens now, we just have the interest that we gained, which is basically the accumulated amount minus the principal amount. Cool. Yes, and we can even see that as the number of times at which our interest is compounded, the interest also increases, right? Yes, but this side of the interest is not really interesting. So the one that I want us to focus on is this one, right? We're going to take all these values and we're going to use them, because these are the accumulated amounts. We're going to use these values to find our effective rates. Remember, I said that our effective rate is the simple interest rate that gives you the same accumulated amount, given that you invested the same amount of principal. For example, so you have P, which is the same, then 1 plus your simple interest is equals to accumulated amount. So this accumulated amount is coming from the values that we have here, and then the principal amount is the same, like in our example we have 1,000 rand, right? So now we're trying to find the interest. We're trying to find the interest, right? So, and I'm going to simplify it. Just right here on this space. I'm going to derive the formula for the interest so that we don't have to do all of that, right? So you have P1 plus I A. So the next step, you divide by P both sides. You have A. Oh my god. A divided by, come on bro, P, then you have 1 plus I. We transpose 1, so you have A over P minus 1. So this is the formula we're going to use, right? So yeah, so I'm just gonna note down these accumulated values. I'm gonna put them here, and then we're just gonna use the yeah. All right, so I have written all my accumulated values there, accumulated amounts. So now we're going to use this formula to calculate the interest rate. So we would say interest. Oh wow. Interest rate will be this value, 1093 divided by P, which is 1,000, minus 1, that gives us 1093, 1000 minus 1, we're getting 0.093, which is exactly 9.3%. You see now, for compounded, for yearly, if the frequency was yearly, the interest is the same, right? 9.3%. We used 9.3%, right? So yearly, just the same. So the reason I put the yearly frequency was to show you guys that if the thing is being compounded yearly, then nominal is the same as effective. But let's see for these other ones here. Oh my god. So okay, here this must have been, let me write it. This is half yearly, right? So here we go again. We have I 109516 divided by 1,000 minus 1. Go to the calculator. 95.16 95.16, we're getting 0.09516. Wow. I'm sorry. And then in terms of percentages, that's going to be 9.52%. Right, now you see the percentage starts to change, right? Let's go again. You have this one. Come on, bro. It's gonna be 1096.29. In fact, let me do this. 6.29 thousand minus 1. Go here. We have 29. That is what? That is 96.9629. Alright, 0.09629, which is exactly 1, 2, 3, which is exactly 9.63%. Right, I want to show you something, guys. Look at the interest we had, 9.3. Look here. You see that that's it's like we have divided each by 10. Yeah, but okay, that's not important. What I was showing, I don't know why I was showing you. I was trying to cook something there, but I don't think it's the correct way. We will check after this. So now I'm gonna post the video again, and I'm gonna write the rest as well as their interest, and then we'll talk. Right, so these are now our interest, our effective interest rate. So just gonna pick it random. I don't know, it's not gonna be random, but okay, let's take this one and let's take this one, maybe those two. Right, we're gonna use these as our interest rates, to find out if we're gonna get the same value if we do the math. So remember, now it's in a form of a simple interest. You have P into 1 plus I, right? That's how simple interest is. P is 1000, right? 1 plus, we have selected 9.63%, which is 0.0963, right? And when we calculate the value, it's gonna be 1000 into 1 plus 0.0963, right? So we're getting exactly 1963, right? And now let's go. Remember, this was the percentage we use this interest, and then when we put that in a calculator, we're getting let's compare this value and this value, right? I think I'm missing something. Yes, I am missing something. You see here, there's a 0.3 which I didn't put. So let's look at the values. Here we have 1096.3. This one is 0.29, which if you round it to one decimal place, it becomes 0.3. Do you see it? Yeah. So now, okay, we can also do the same with this one and say blah 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 blah. That's 1000 into 1 plus 0.0975, right? The interest is 0.0975, and wait, is the last one cool? Is the last one. So now compare this value right here and this value right here. You see, if you round it up to one decimal place, you have exactly the same values. Do you see that? So now what can we now say, right? Okay, let's forget about that. What can we now say? We have seen now we have actually saying that you have P being your principal. If you do the math, um, n times m, right? This, it gives you your accumulated amount, right? And we have actually noticed that we can find value with the same p. Let me say effective. We can find the effective interest rate, which is the simple interest rate that will give you the same accumulated amount, right? We have found that to be the case, right? I just need to confirm here if I did mistake, and then we're gonna go into the derivation. All right, cool. Now everything is fine. I just need to remove come on, I just need to remove this value, put this one. So yeah, so everything is fine now. We did calculations where we did our compounded quarterly, yearly. Those m represents the periods, those quarterly, yearly, half yearly, whatsoever. And then we were able to find the effective, right, interest rate, which is a simple interest rate that gives us the same accumulated amount. So now we'll just say A equals to A, which you find that you have P into 1 plus I, let's say effective. Then you have P1 plus I, let me say norm m to the power of m. Right, in the p they cancel each other out, so you have 1 plus I effective equals to 1 plus I norm divided by m all to the power of f. Right, so basically you can then, after this, you can then transpose this one to go this side and be like minus. Then we have a formula for your effective interest rates. Right, I think now we good for some examples. Let's see what we got. Let's see what we got. Ezekiel, so in the middle of the air. Okay, consider the following interest rate. So we have 16, they are all per annum. We have 16.8 annually, 16.4 monthly, 16.5 quarterly, right? Determine the effective rate. Halala, good example. Determine the effective annual interest rate of each of the following nominal rates listed. So just like I said, remember these are nominal, right? And if you just go back a couple of minutes, you'll see that the formula we just derived, it says that, okay, the formula, it says that effective interest rate is equals to, you have 1 plus I for nominal. Let me just leave the nominal one like that. You have m minus 1, right? So we're gonna do exactly the substitution here to say, okay, let me just say for a, I'm just gonna substitute without using the formula, because the formula is just there. So the effective rate is gonna be 1 plus, here we have 16, no, 0.168 divided by 1, because it's compounded annually, and 1 minus 1, right? Put that in a calculator. 0.168 divided by 1 is just the same thing, bro. So this is basically what we have. After to the power of 1 divided by 1, this is what we have. Then we minus 1, so you're getting 0.168, which is exactly 16.8%. Do you see it? When it's annually, the effective interest rate and the nominal interest rate are exactly the same. Let's do number 2. B, we have 16. 16.4, no, 0.164, monthly 12 minus 1. Cool. I'm just gonna go here, that is 4, and then 12 to the power of 12. Yes, 164 divided by 12 because it's monthly. Yes. So I'm getting 0.1769, which is 17.69%. And then C, okay, it's 0.5 EFF. Here when EFF, even 1.0165. This one is quarterly, so that is 4 minus 1, 4, then I have 5, 0.175, 17.55%. But we have found these are all our effective rates for all of the numbers up there. And then they ask you a question, they say, which is the best interest rate for an investment? Yeah. So you see, like, this things of effective rates. When you have effective rates, you can now actually see which interest offers the best, rate, right? And how do you do that? You find the highest, which is this one right here, is the one with the highest value. So of course, this will be your answer to say the second option is the best one. It's the better one. Yeah, because it has the highest, it offers the highest amount of interest. And then, cool. Yeah, because like when you make an investment, you want to get a lot of money. You want to have higher returns. So higher interest means higher returns. And then, which is the best interest rate for a loan? So now remember, if you are paying a loan, if you took a loan and now you're going to pay someone back, you want a loan that's not going to charge you too much interest. So you want the lowest interest rate as possible. So this, in this case, is going to be your answer, to because it's the lowest interest rate we have here. So yeah, so if you took a loan, this is the value you're going to want. You know what I'm saying? Yeah, let's see what we have next. All right, cool. So I think these are, yeah. Oh, we actually done. So that's just what effective interest rates versus nominal interest rates are, right? Yeah, I'll see you guys in the next video. In the next video, we are going to talk about, we're going to solve problems. I'm done with the topic. I'm done with finance topic. We're just gonna solve a couple of questions from an exam. I'll see you there, guys. Enjoy yourself. Bye.